guys, thanks for joining me for the fourth and final video of Unit 5. And so we talked about Lewis dot structures, we've talked about naming stuff, we've talked about molecular geometry, and so I want to start this video talking to you about formal charge, which is just kind of remembering a formula and plugging some numbers in, so pretty easy. So the formal charge for any atom in a compound is always its number of valence electrons, which all of you know how to do. You just look on the periodic table and see what column it's in. Subtracted by the number of bonding electrons, subtracted by the bonding electrons divided by 2. So I'm going to do a couple of examples with you. I'm going to start with this oxygen right up here. All right. Oxygen has 6 valence electrons. Minus non-bonding electrons. Those are dots that aren't bonded to anything. So how many of those do I have? 1, 2, 3, 4. Okay. Minus bonding electrons divided by 2. Okay. So all of these are bonding electrons coming out of that oxygen. And each line represents 2 dots. So 1, 2, 3, 4. There are 4 bonding electrons divided by 2. 6 minus 4 is 2 minus 4 divided by 2. The formal charge of that oxygen is 0. Now, are the other oxygens going to have the same formal charge? I don't know. Let's see. So this oxygen has 6 valence electrons minus non-bonding electrons. How many dots are around it? 1, 2, 3, 4, 5, 6. Minus bonding electrons, 1, 2, divided by 2. So I have 6 minus 1 equals -1. That's how you will find the formal charge for any atom in your compound. The last thing I talked about in your notes was polarity. The gist behind polarity is if you do the Lewis dot structure and your structure is totally symmetrical, it's going to be nonpolar. So if you look at a substance that's symmetrical, for instance, this is symmetrical. It has 4 items coming off of the carbon and each item is a hydrogen. It's nonpolar. But if you look at something like this, okay, it is not symmetrical. And because it's not symmetrical, the electron density is not shared equally. So it makes it nonpolar. Now, there's a special way as chemists that we illustrate that at times, and it's called by drawing the dipole moment. And all you're really doing is you're drawing arrows everywhere you see bonds, and the arrows point to the most electronegative atom. And if you remember from a couple of units ago, when you look at the periodic table, the closer you are to F, the more electronegative you are. So your arrow is going to point to the element that's closer to F. In this case, it's F. So my dipole moment or my arrow points that way. We like to be a little fancy in chemistry, and we put a little plus here. And the reason we're doing it is this dipole moment or this arrow shows electron density, okay? So there's more electron density on this side of the bond than this side of the bond. And when that happens, this almost takes a partial negative charge, and I can draw that, this is a weird little thing here, partial negative, and this becomes, sorry, I had a little mini stripe there, partial positive. So there's a little more electron density over here, so it's negative. And this becomes a little more positive. Are they true positive and negative charges? It's just little partial charges there. This concludes all of your notes for Unit 5. There's a lot of stuff in Unit 5. It's not that hard, but it is going to require a little effort and a little review. And you guys are so smart, it'll be so easy. I'll see you in class soon. Take care. Bye.